Next, we're going to start looking at probability more specifically and using our counting and permutations and combinations to help us calculate probabilities. And so a couple of really important definitions that are going to sort of follow through our discussion of probabilities. First one is an experiment. So it's any occurrence in which the outcome is uncertain is called an experiment. Okay, and I've got some examples up here. An occurrence might be a coin toss, or a die roll, or you're dealing cards, right? Cards that are dealt, a vote in an election, etc. Anything that's uncertain, any future event or current event that has some uncertainty as to what's going to happen is considered an experiment. If you take all the possible outcomes from the experiment, then that's called the sample space. So for instance, just kind of being consistent here with the ones from above, coin toss has a sample space of either heads or tails. A die roll has a sample space of 1, 2, 3, 4, 5, 6, right? This is the only a six-sided cube, right, that you're rolling a die. Cards dealt, well, you have 52 options, right? You have ace of spade, ace of club, ace of heart, ace of diamond, two of spade, two of club, and so forth. There's 52 of them. And so that's a pretty big set. I didn't write them all out, obviously. And then, a vote in an election, let's say a Democrat, Republican, or independent or something like that. So you have some options and it's uncertain as to how that will turn out. And so those are the sample spaces or examples of sample spaces. So it has all of the possible outcomes from that one given event, like flipping a coin, what the options are. Those are the individual options are the experiment, and the set of all possible outcomes is the sample space. Okay, so take all of them together, you get the sample space. An event is any subset of the sample space. All right, so some examples of corresponding events. If you take the sample space of heads and tails, maybe an event is a head, right? You flip it, you get a head. It's either a head or a tail, right? Of course, you could have an empty set or the actual full set, but it's any subset. Let's say here I have an event of rolling an even number, right? So you get a 2, 4, or a 6. With the cards, maybe I have X, such that X is a heart. So the event is that you're dealt a heart, right? That's going to happen roughly 1/4 of the time because there's 4 suits and a quarter of the cards in the deck are hearts. For the voting, let's say an independent wins, which that rarely happens, but let's just go with it. That is an event within the sample space. Okay, it's a subset of the sample space. Now, probabilities are defined based upon all of this stuff. Probability of an event, which is denoted as P of E, is equal to the cardinality. So now we're looking back on what we learned in set theory. The cardinality of E, which is the size of E, the number of elements in the event, divided by the cardinality of S, the number of elements in the sample space. Okay, so the number of elements in the event divided by the number of elements of the sample space. So if I go back to these specific examples here, we can look at the probabilities and calculate them very simply, just creating a fraction and reducing it. And so the probability of a head, if I go with that particular event, we'll just kind of keep it consistent, is going to be the cardinality of this set, which is 1, divided by the cardinality of the sample space, which is 2. It's the number of elements in the set. So 1/2. So half the time, 50%, going to be heads, 50% tails, okay, in theory. Let's look at probability of getting an even dice roll or die roll. You have 1, 2, 3 elements of the event. You have 6 elements of the sample space, and so we reduce that down also to 1/2. Okay, so that one's actually equivalent to the first one. But of course, there are other events within this sample space that would have other probabilities. We look at probability of getting a heart. Well, in that case, there are 13 hearts, so the size of set S, I'm sorry, oh, did I put S there? Those should have been E's. What am I doing? I don't know why I put S's there. I even prepped that ahead of time. Those should have been E's. My bad. Okay, good thing I caught that at some point anyway. The probability of event E is a heart, and well, there are 13 hearts in a deck, and the probability or the number of elements in S, well, there are 52 cards in the deck, right? So the cardinality of E is 13, the cardinality of S is 52. When you divide them, you get 1/4, or when you reduce that fraction down. Both are divisible by 13. And finally, here, now I'm assuming, one of the interesting assumptions here is that you have to assume, in order to make this all work out, that these are equally likely outcomes. Now, in the first three examples, I think it's obvious that each individual outcome is equally likely, right? A coin toss is equal, heads and tails are equally likely. The numbers 1 through 6 are equally likely. The cards in the deck, if you shuffle that deck up, they're equally likely to occur. Now, with the voting situation, maybe they're not so equally likely. Okay, maybe it's closer to 45%, 45%, 10% chance of coming out with a certain result there. But for the sake of this example, I'm going to assume that they're all equally likely. Okay, and of course that will vary. Now we'll get into different probabilities or weighted probabilities later on, but for right now we'll just assume they're all equally likely. And so in that case, the probability of I occurring, assuming that it's a 1/3, 1/3, 1/3 probability, or they're equally likely, I should say, I already spoiled it. They're equally likely, you get a 1/3 probability, right? So it's I is 1/3. So it's the cardinality of E over the cardinality of S. It's 1/3, gives you a 1/3 probability, okay? Now, probabilities are always between 0 and 1, okay? Inclusive. You could have a 0 probability event. You could also have an event with probability 1, which is certainty. And that's basically like, if I'm rolling a dice, the chances of getting something less than a 7 is certain. It's 1, right? It's 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. And we'll talk about adding probabilities and multiplying probabilities and working with probabilities in future videos. But for right now, just kind of know these basic definitions: experiment, sample space, event, and then probability. I really should underline probability because that's also a definition. And of course, the probability in general is the cardinality of the event divided by the cardinality of the sample space when the event and the sample space are both sets.